We're back with graphs. We are going to take some of those basic graphs that were pointed out in the last section and start really diving into what we can do with them, with those functions and how we can graph them. We're going to be looking at shifting and reflecting and all kinds of things that happen because, y equals x squared, for example, isn't the only form of your squaring function. You can have that shifted around, left, right, up, down. You can have it stretched, shrunk, reflected. So, we're going to be looking at the ins and outs of manipulating these functions to have, other forms of them, starting with vertical and horizontal shifts. Okay, vertical shifts. For positive value c, so some positive number, you can take your function, y equals f of x, and add c to it, and that will take whatever the graph of your function was, it'll shift it up that many units, whatever c is. If you subtract c, that'll shift your graph down c units. So what, you take your entire function, add a number to it, that'll shift it up, the graph up that number. If you subtract a number from it, that'll shift the graph down that number. So let's check this out. Okay, let's start with y equals absolute value of x, or f of x equals absolute value of x. Now f of x, remember, is function notation, fancy way of writing y. Let's start with absolute value of x. Absolute value of x, you'll have some values. You'll have 0, 0, 1, 1, 2, 2, etc. Negative 1, 1, negative 2, 2, etc. Those are just some ordered pairs on your absolute value of x function. Okay, and I'll do my best here to draw the graph straight. Remember, absolute value looks like a V shape. Okay, so that's the basic form of the f of x equals absolute value of x. But what if we decide that we want to do some shifting? Okay, let me change my color here. We can keep track of which one's which. Maybe I'll do the next one blue. All right, let's say we have f of x equals absolute value of x. So far, notice it looks exactly like the other function, except now we're going to do a plus 3 on the end here. Okay, so what that does is it takes every point on this f of x equals absolute value of x function, and it shifts them up 3. So 0, 0 hops up 3. 1, 2, 3 to here. So now you've got the point 0, 3. So notice you're shifting up 3. All these y values in these points are going to increase by 3. 1, 1 shifts up 3. 1, 2, 3 ends up here. And you're left with 1, 4. 2, 2 shifts up 3. 1, 2, 3. You end up right here. You end up with 2, 5. If you go back and look at your function, it makes sense. If you plug in 0, absolute value of 0 is 0, plus 3 is 3. So there you got 0, 3. Plug in 1, absolute value of 1 is 1, plus 3 gives you 4. Okay, if you plug in negative 1, the absolute value of negative 1 is 1, plus 3 gives you 4. So this point right here shifts up 1, 2, 3. If you plug in negative 2, absolute value of negative 2 is 2, plus 3 gives you 5. So this point here shifts up 1, 2, 3. So all the points in the graph shift up 3. I just use these points for getting the location, but you can go ahead and connect the dots and show that every single point on the graph shifted up 3. And that's what happens if you add 3 to the function. If you add any number to a function, it will shift it up that many units. Okay, now let's change the color. How about we do orange? Promise I'm not a Florida Gator fan, just seemed like a nice contrasting color. All right, let's do this again, but let's do f of x equals absolute value of x minus 2. Okay, if you start with 0, absolute value of 0 is 0, minus 2 gives you negative 2. So from the black graph here, 0, 0 shifts down 2. You get 0, negative 2. Subtracting 2 is going to shift that whole graph down 2. So you put in 1. Absolute value of 1 is 1, minus 2 is negative 1. So you get 1, negative 1. Let's say you put in 2. Absolute value of 2 is 2, minus 2 is 0. So you get 2, 0. Notice all these points so far are shifting down too. Negative 1 shifted, negative 1, negative 1, 1 shifted down 2, 1, 2. It's going to end up right here at negative 1, negative 1. I lost my pointer for a second here. Where is it? There it is. Because if you plug in negative 1, absolute value of negative 1 is 1, minus 2 gives you negative 1. Plug in negative 2. Absolute value of negative 2 is 2, minus 2 is 0. So this point shifted down 2. So subtracting 2 makes everything shift down 2. And there you have it. So that's a shift up or down for a function. Okay, next shift. Horizontal. What if you want to shift left or right? For a positive value c, y equals f of x minus c, subtracting the c from the variable directly, results in the graph of y equals f of x being shifted right c units. For a positive value c, y equals f of x plus c, the addition of c to the only variable results in the graph of y equals f of x being shifted left c units. Okay, so adding or subtracting directly to the variable will shift it left or right. On this one, to me, the signs are opposite of what my instincts want to say. Like when I see subtraction, to me it should go to the left, but actually here it's going to be a shift to the right. And when I see addition, I feel like, oh, that should be going to the right, but actually it's a shift to the left. Let's do an example and you'll see why that happens. Okay, let's take that squaring function. Let me start in black again. All right, let's start with f of x equals x squared. Okay, f of x equals x squared. You plug in 0, you're going to get 0. Plug in 1, you're going to get 1. Plug in negative 1, you're going to get 1. Plug in 2, you're going to get 4. Plug in negative 2, you're going to get 4. That's just some points to get us started. We learned from that little function capsule that the shape for this is a parabola. So if you at least get some points to get you started and then know the shape, you can fill it in, sketch it in. Parabola's a little more rounded, but I'm having a hard time drawing here. Okay. But you get the idea. It's a little bit sloppy, sorry. So there's your squaring function, your parabola. But what if you do some adding or subtracting with your variables? Okay, so earlier I'd used blue, so let's do that again. I like blue. Let's do f of x equals parentheses x plus 2 close parentheses squared. Okay, so we are adding 2 directly to the x. All right, let's say we go ahead and plug in 0 for x. 0 plus 2 is 2. 2 squared is 4. Huh. Here I had 2 comma 4. Here I have 0 comma 4. To get the same y value, my x value shifted to the left too. So let's see, what about, well, if we plug in 1, 1 plus 2 is 3, 3 squared is 9. Oh boy. So I'm getting an extra point that I hadn't graphed earlier. If I had graphed this one earlier, I would have had 3, 9 up here. Okay, so let me take values going towards the left. Let me take -1. -1 plus 2 is 1. 1 squared is 1. Let me take -2. -2 plus 2 is 0. 0 squared is 0. Take -3. -3 plus 2 is -1. Squared is 1. And then -4 plus 2 is 2. Squared is 4. That's probably enough. And this is what I had earlier, but then I ended up doing an extra point, you know. But you can see it's a shift to the left too. When I added 2 to the x, directly to the x, you know, it's in parentheses here, so it's being added to the 2, I shifted left 2 because I had to compensate. To get the same y values, I had to compensate by subtracting 2. If I added 2 here, then to get the same y values, I'm going to the left 2 or subtracting 2. So like what, you know, before 0, x value of 0 gave me a y value of 0. I had to subtract 2 and get -2 comma 0 here. So adding a number directly to x will shift to the left that many units. I'll do the orange again. Hope you guys can see it. So then subtracting a number shifts it the other direction to the right. So let's do x minus 3 quantity squared. All right, so that'll take like this point and shift it to the right 1, 2, 3. Because if I plug in 3 now, 3 minus 3 will give me that 0 I need. Subtracting 3 from x means I have to add 3 to the x values and like compensate for it. Like it's almost like you're canceling it out in a sense. So all those original points are shifting to the right 3. So this point, 1, 2, 3. 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 And there's that. So like you have 1. 1 minus 3 is -2. Squared is 4. You have 2. 2 minus 3 is -1. Squared is 1. We already have 3 comma 0. You have 4. 4 minus 3 is 1. Squared is 1. You have 5. 5 minus 3 is 2. Squared is 4. So notice it's shifting, you know, subtracting 3 means all your x values went up 3 to get the same y value results. Okay. Now as you shift, pay attention to what's happening to your domain and range. Always check to see how domain and range are being affected by shifts. If your domain is -infinity to infinity, doing a horizontal shift isn't going to affect the domain, because if you shift it left or right and it's already extending forever to the left or right, shifting it left or right is not going to make a difference to your domain. Same concept with range. If your range is -infinity to infinity, shifting it up or down is not going to affect the range. But otherwise, other situations, you need to pay attention to what's happening. Okay, for instance, let's say you have, let me change my color back. I like black. shows up best. All right, let's say you have this function here. Okay. We look at the exponent, and that gives us information about what the original function looks like. Original function is f of x equals x cubed. Okay, so there's our original function. Again, forgive the terrible drawing. Anyways, you can see what's going on there. Okay. Now, approach this with thinking like order of operations. You know, you're looking at your exponent first tells you at least what the original function should look like. Then going inside parentheses, just like an order of operations, you see the plus 2, you see the 2 being added directly to x. So remember, within that area, if you see a plus, that means it's shifting to the left. Now, your original domain for f of x equals x cubed, your original domain is negative infinity to infinity. Your original range is negative infinity to infinity. So shifting left, right, shifting up, down is not going to affect your domain and range. So when you hit f of x equals x plus 2 cubed, okay, you're shifting left 2. Shifting all your points to the left by 2 units. Notice your domain and range are still the same. Okay, and then when you go outside of the parentheses and see that minus 4, that's telling you now to take the x plus 2 cubed and shift that down 4. So that's going way down there. So then that final graph, I can see it on your video screen, but if you download the slides, you'll see it on there. That final graph looks like this. It's a little sloppy, sorry. Notice still domain is negative infinity to infinity. Range is still negative infinity to infinity. But let's do one where you're definitely going to see a change in your domain and range. Let's do one with square root. Let's see here. Let's take, ooh, that looks like a good one. Let's do f of x equals square root of x minus 2 and then plus 1. All right, so looking under the square root first, the square root tells us we're dealing with the square root function. Square root function, when you graph it, looks like this. It's like half of a sideways parabola. It's going like that. Square root function has a domain of 0 to infinity and a range of 0 to infinity. Okay, now I really should just not be lazy and change colors here. Let's do blue again. All right, looking underneath the square root sign, that's it's a grouping sort of symbol, so we need to tackle that first and do square root of x minus 2. We're subtracting 2 directly from x, so that means we're going to be shifting everything to the right 2 units. Okay, so notice the domain has changed. The domain is now 2 to infinity. The range has not changed though. Shifting left or right can't affect the domain. We shifted to the right, so now the graph starts at an x value of 2 and then shoots off to positive infinity. But the range is still the lowest y value is 0. But range was not affected there. I'm not sure if orange showed up, so I'm going to do red. I'm not trying to like shout at you guys, but I think red might show up better than orange. All right, f of x. Now we can tackle the outside there, that plus 1. Adding 1 on the outside like that means we're going to shift everything up 1. So we're going to take the blue graph we just did, and oops, sorry, you erase that. All right, going back to the pin. Okay, shifting everything up 1. We got right here, got right here, got right here, we got right here. So now this is the final result. And notice now, domain is still 2 to infinity because we didn't shift left or right again, but now the range has changed to become 1 to infinity. Since we shifted up 1, we added 1 to this 0 and got 1. In infinity, you don't really change. And earlier with the domain, we shifted right 2, so we'd added 2 to this 0. If you shift left, you're going to subtract, or if you shift down, you're going to subtract. So the domain and range are affected by how you're shifting. Okay, well that's all the examples I wanted to show you for now with vertical and horizontal shifts. Next lesson, we're going to look at stretching, shrinking, and reflecting. And that's where it's going to get really fun. And then that will give you everything you need to have fun with graphing. Okay, so thank you for joining us, and please do join us again soon.